All right, so again, when we factor, no matter what we're looking at, how many terms we have or anything, the very first thing we always want to ask ourselves is, do we have a GCF? Okay, so if I'm looking at number 1, 2x squared plus 5x minus 3, do all three of those terms have something in common? No. Okay. This one is different than yesterday. Why? What is it? What looks different about it? Look at your x squared term. Yesterday, all the ones we had, it was just 1x squared, right? So today, we're going to have some numbers in front of x squared. This is called factoring when a is not equal to 1. The difference is we are not just focused on the last term anymore. We have to focus on the last term and the first term. This is also taught several different ways as far as how to factor. How many of you have heard the cloud method? Okay, that is one way you would factor these. It's not a bad way. It just, to me, is a little bit more time-consuming than it has to be if you just remember a couple of rules. If you're comfortable factoring the cloud method, you are welcome to continue to do that. I'm going to do the first couple showing you the rules that I use, and then if you would like, I can show you also the cloud method just to kind of refresh on that. So what we're going to do is we're going to start with that 2x squared plus 5x minus 3. And we want to, first of all, think about what it is we're trying to do. We're still focusing on that second sign and the middle term, okay? We want to be able to subtract to get 5. But today, we can't just worry about the factors of 3. We also have to include those factors of 2 as well. So the very first thing I want to do is I want to list the factors of the first term, that 2. What are the only two factors of 2? 1 and 2, okay? And then I list the factors of the last term. What are the only factors of 3? 1 and 3. Okay. That means I have to use 1 and 2, and I have to use 1 and 3 if this thing is going to factor. I just have to figure out where the placement is going to go. So I'm going to set up my 2 parentheses. And in the beginning, I have a 1 and a 2, so I'm going to have to split that up with my x's as well. So in one parenthesis, I'm going to put a 2x, and in the other parenthesis, I'm going to put a 1x. Now, keep in mind, we are trying to subtract to get 5 at the end of the day. Then for my second term, or my last term, the only factors I have are 1 and 3. I just have to decide where I'm going to put the 1 and where I'm going to put the 3. Sometimes it's just a guess and check, okay? I'm going to start with putting the 1 in the first parenthesis and a 3 in the second parenthesis. When I'm trying to subtract to get 5, I can't just look at the 3 and the 1. I have to look at the product. So what I want you to focus on is this. We're going to multiply the, multiply the first term and the last term. What does 2x and 3 give me when I multiply those? It gives you 6x, right? And then I multiply the middle 2 terms. What do I get when I multiply 1 and x? 1x. I want to know, do those subtract to give me 5? Does 6 and 1 subtract to give me 5? It does, okay? So I had my placement correct. If I had put the 3 first and the 1 second, that would not have worked, and I would have had to switch them. Now we have to figure out our signs, and our signs are going to be exactly the same as yesterday. Remember, if our second sign is a minus, that means my signs are going to be different. I'm going to have 1 plus and I'm going to have 1 minus. And this first sign is going to go in front of the bigger number. But in this case, we have to focus on the bigger product, the 2 that we multiply. 6x and 1x. What's bigger, 6x or 1x? 6x. So I need that 6x to be positive. So therefore, I'm going to put that plus sign in front of the 3 because that's what I multiply with the 2, okay? So that gives me a positive 6x and a negative 1x, which does combine to give me a positive 5. Now, it works out that 3 is bigger than 1, and that does work majority of the time. Every now and again, it won't. I would say it works probably 98%, so I'm just looking at 3 and 1. Is everybody okay with that? So to factor that, that would be the answer, 2x minus 1 and x plus 3. Now, if you are a fan of the cloud method and you'd like to do that, I just want to refresh how that works. Okay. So what we do on the cloud method is we take this first number, this 2, and we pull it off to the side and you put it in your little cloud bubble, whatever. And that's not the official name for it. Some teachers call it different things. And what we do is we rewrite this without the 2. We keep that middle term the same. And does anybody remember what do we do with that 3 and that 2? Multiply them, so that becomes 6. Okay. Now this looks like what we did yesterday, right? The easier type. So we want numbers that multiply to give us 6 and subtract to give us 5. Numbers that multiply to give us 6 and subtract to give us 5. It's either 1 and 6 or 2 and 3. Which one subtracts to give me 5? 1 and 6, okay. And I'm going to go ahead and place my signs. This means my signs are different. This one goes in front of the bigger number, so it's a +6 and a -1. That doesn't look like the answer I have over here, does it? No. Okay. Because we still have this 2 out here floating around that we have to bring back into our problem. So what we do is we take that 2 and we put it under each one of these terms. If these can reduce, we reduce them. Does 1 and 2 have anything to reduce by? Do 6 and 2, those reduce, yeah. Okay. So in this case, because it doesn't reduce, this 2 is going to go floating right in front of that x. Like that. And then this one, 6 divided by 2, does reduce all the way down to be 3. And you see how we got the same thing? It doesn't matter to me which way you do it. This one, sometimes when you add more stuff in besides the factoring, can be a little bit longer, but some people feel more comfortable with this because it's really just a process that you follow instead of having to think and guess and check on things. All right? Does that make sense? Okay. Let's take a look at 2. We're going to try this one together. I've got 3x squared minus 8x plus 5. My very first question, do I have a GCF? No, I do not. All right, so again, keeping in mind what we're trying to do, we want to add to get 8. We want to add to get 8. I have to list the factors of my first term, 1 and 3. Factors of my last term are 1 and 5. Good news is that's the only option here, so it's not going to be a lot of guessing and checking, maybe just rearranging a little bit. So I'm going to set up my 2 parentheses. Hold on. This is not wanting to write very well. Sorry. And in the first, I'm going to put a 3x and a 1x in the front. And then I just have to decide where I'm going to put my 1 and my 5. So I'm going to do the process like I did before. I'm going to put the 1 first and the 5 second. What I have to do is check the products. What do I get when I multiply 3 times 5? 15. If I'm trying to add to get 8, is 15 already too much? It is, okay? So what that tells me is the placement is not correct. That 5 and that 1 is not in the correct position. So what I can do is I can just switch them around and try it the other way. Then I'm going to also try my products, the outside 2. 3 times 1 is how much? 3. And then 5 times 1x is 5. I'm not thinking about the variables, just the numbers. Do 3 and 5 add to give me 8? They do. Okay, so that tells me my placement is correct. Then I go to my signs. Am I going to have the same signs or different signs? Same signs. And they're both going to be what the first sign is. Remember, this tells me they're the same. This is what they both are, which gives me 3x minus 5 and x minus 1. Okay, a little bit harder than yesterday, but not too terribly difficult until I get some bigger numbers with lots of factors. Is everybody okay? Do you want me to do that one, cloud method too? Yeah? Okay. All right, so I have 3x squared minus 8x plus 5. So the first thing we're going to do is pull that 3 out. We rewrite the first term and the middle term exactly the same. And we multiply. 3 times 5 gives me 15. I factor this one as it is. I want numbers that multiply to give me 15 and add to give me 8. Which are what, 3 and 5? Same signs, both negative. But we can't forget about this 3, so we have to bring that back in. It goes under each one of my second terms. What does 3 divided by 3 reduce to be? Does 5 over 3 reduce? No. So this 3 is going to then come in front of that x, and it turns into 3x minus 5, which is the same thing. It's just different order, but the order doesn't matter there. The only bad thing about the cloud method is if it has a GCF and you go straight into doing the cloud method without pulling that GCF out, the cloud method is going to cancel out your GCF. So it's going to make you miss. That's where you just have to be very careful with that. Yes, sir. Yes. Do I have any questions? All right. I want you to try 3. Okay. Either method, whichever you like. You can do the cloud method, or you can do the way that I showed you. And then on this method, I want to tell you a couple more rules as well that can help you when you start getting numbers that have multiple factors. Just test it out and see which one works on this. So let's check that. We want to add to the page. about 4? Are 4 and 1 the only pair of factors for 4? What else? If 4 and 1 don't work, what else could we try? 2 and 2. Okay. This is when people start to get frustrated because it doesn't always work the first time like it did yesterday. A couple of rules I wrote up here that can kind of help you sometimes eliminate possibilities when you have multiple pairs of factors. If your middle term is even, then you can't use a pair of even and odd factors. And what that means is you can't use a pair of factors that has one even number and one odd number. Okay? If the middle term is odd, then you can't use a pair of even factors, which means you can't use a pair of factors that are both even. So let's start with this one. So I see some people struggling, and this is probably not the good one for me to let you try on your own since we hadn't done one like this. First of all, 4x squared, 8x, and 3, do they all have something in common? No. So we need to first list the factors of 4, which are 1 and 4, but also 2 and 2. And then we're going to list the factors of 3, which are just 1 and 3. We want to keep in mind what we're trying to do. We are trying to add to get 8. Okay. Now, because I have 2 options for my 4, I could use 1 and 4 or 2 and 2. I want to see if my rules might help me. Sometimes they help, sometimes they don't. My middle term is 8. Is that even or odd? It's even, right? So my rule says if my middle term is even, then I can't use a pair of factors that has one even number and one odd number. Do any of the factors of 4 have one even number and one odd number? Which ones? The 1 and the 4. So what that tells me is that is not an option. I can't use that because of that rule. Now, if you don't remember the rules, you can try the 1 and the 4. It's not going to work either plus, okay? Whether you switch the 3 and the 1 or not. So what that tells me now is using that rule, I know that I'm going to have to use the 2 and the 2. And the only option for 3 is 1 and 3. So then I'm going to try my products. What is 2 times 3? 6. And 2 times 1 is 2. Does that add to give me 8? It does. What about my signs? Are they going to be the same or different? Same, and they're both going to be plus. If you wanted the cloud method, okay, pull off the 4, multiply 3 times 4, factor this. Factors of 12 that add to give me 8 would be 2 and 6. Signs are going to be the same. They're both positive. But now I have to bring that 4 back in. And this sometimes also confuses people with the cloud method. Does 2 over 4 completely reduce? It doesn't reduce to be a whole number, but they can both divide by what? 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. I'm going to do the same thing over here. What about 6 and 4? What can they reduce by? 2. So that gives me 3 and 2. However, we don't leave fractions in our factoring problems. So if you still have a fraction, that denominator, that bottom number, is going to go in front of the x. And the same thing over here. This one is going to go in front of that x. And isn't that the same thing that we got the other way? All right, let's take a look at number 4. What I want you to do first, do we have a GCF? No, right? Okay, so list the factors of your first term. List the factors of 4. And then list the factors of 15. Okay, I usually just do it right out to the side. List the factors of 4. One and 4 and 2 and 2. And then the factors of 15 are 1 and 15 and 3 and 5. Now, I want to try to see if any of my rules help me. Is my middle term odd or even? It's odd. And so this one says if your middle term is odd, then we can't use a pair of even factors. Do I have a pair of even factors with the 4? I do. So what that tells me is I can't use 2 and 2. Those are not going to be a good option. Not going to work because of that rule. What about the factors of 15? Do I have a pair of even ones there? No. Okay, so it doesn't really help me on that side, but it did at least eliminate one of the options for the 4. But we want to keep in mind what we're doing. We're adding to get 17. Come on. So I'm going to use the 1x and the 4x. And then knowing which one to try. Do I try 1 and 15? Do I try 3 and 5? Keep in mind, we're trying to add to get 17, correct? Well, just think about this. I have to use 4 because that's an option. If I use 15, think about this. If I add 4 and 15, isn't that more than I need already? Okay, so that's just thinking about it without having to try it sometimes will help you say, well, that's not going to get me where I need to go. Also, on that last term, especially when you have some larger numbers, it is very rare that we use 1 in that number. Okay, that's usually the last thing I check. I usually check all the smaller factors first. But what we have to do is check and see which one goes where. So I'm going to try to put the 3 here, and I'm going to try the 5 here. This may or may not work. Okay, again, we're checking the products. What is 5 times 4? 20. That's already more than 17, isn't it? So I don't need to try the other one. So what I need to do is I need to switch the positions. I'm going to try to put the 5 here and the 3 here, and I'm going to try again. What is 4 times 3? 12. Okay, and then if we do 5 times 1, that is 5. Does 12 and 5 add to give me 17? Okay. What about my signs? Are they going to be the same or different? Same, and they're both going to be minus. Again, I don't care if you do it the way that I'm showing you or if you do it the cloud method. Whatever you're more comfortable with. I would just say, with that cloud method, make sure that you always look for a GCF first, because if it has one, the cloud method is going to divide that out and you're going to lose it as part of your answer. Are you okay with this? They're a little bit harder. They take a little bit more time sometimes. Try 5. Hold off on 6. Do we have a GCF? All right. So let's list factors of 6. That would be 1 and 6 and 2 and 3. And then factors of 10 would be 1 and 10 and 2 and 5. I am trying to subtract to get 7. I want to see if my rules help me eliminate any options. My middle term is odd this time, right? So I can't use a pair of even factors. Do I have a pair of even factors anywhere? So that really doesn't help me. So what I have to do is I have to decide with that first term, am I going to use 1 and 6 or am I going to use 2 and 3? First one, we use the 1 and the big number some more often than we do with the last term. So I'm going to start with the 1 and the 6. And remember what I told you about this last term. I rarely use that large number. So I'm going to start with the 2 and the 5. If that doesn't work, then I will change it to the 1 and the 10. However, another thing we need to be careful of. When I decide the placement of my 2 and my 5, one of the numbers is not allowed to go in the parentheses with the 6 because they have something in common. Think about 2 and 5. Which one of those have something in common with 6? 2. Okay. So if it's going to work with 2 and 5, the 2 is not allowed to be with the 6. So the only way I could work this is like that. Okay? Because you can't put something in common in the same parentheses. So that also helps me eliminate a choice. Now let's check our products. What is 6 times 2? 12. And then 5 times 1 is 5. Does 12 and 5 subtract to give me 7? It does. My signs are going to be different because of this minus sign. And then I have to make my bigger number positive, but we're talking about the bigger product. What's bigger, 12 or 5? 12. So in order for that 12 to be positive, does the number go in front of the 5 or in front of the 2? I mean, does the plus go in front of the 5 or the 2? In the 2, okay. So in this case, it didn't work out to focus on just the 5 and the 2. You have to focus on the product when you're talking about the bigger numbers there. And so this one factored. It's just like that. Everybody okay? All right. If you haven't already, write down number 6. This one is different for a couple of reasons. First of all, I do have a number in front of my x squared, but what else is also different? What do I have in this one that I haven't done yet? I have another variable, right? I have a y squared, and then I have an x and a y. Okay. You said they can simplify, which means they have a what? They have a greatest common factor. So let's look at that first. What is it that all 3 terms have in common? A 2. So what we want to do is pull that 2 out first. When I factor out that 2, look in the parentheses. Is that more like today's stuff or yesterday's stuff? Yesterday's, right? So we don't have a number in front of our x squared. What we do have that is slightly different is we also have a y squared. That doesn't change anything other than the fact that we're going to add another variable in our problems. Okay, so what I want you to look at is we want to think about, we want numbers that multiply to give us 5 and subtract to give us 4. What numbers multiply to give us 5 and subtract to give us 4? 5 and 1. Here's the only difference. We put the x's in the front, add the y's in the back. So a 5y and a 1y. Okay, I'm still using 5 and 1. I'm just sticking another variable on. Are my signs going to be the same or different? Different. And the first one goes in front of the bigger number. What's bigger, 5 or 1? 5. So we're going to put a plus 5 and a minus 1. And that is what that one looks like. Okay, so when they throw that second variable in there, it doesn't change how we're thinking about it. It just changed how it looks to be able to stick that second variable in the back of the parentheses. How do we feel? I feel like I'm rushing, but also we're on top of the schedule, so we don't have much more time. Let me let you try. I want you to try 9. Okay. All right, looking at 9, 4x squared plus 3x minus 15. Do we have a GCF? No. All right, so we're going to list the factors of 4, which are 1 and 4. Except for it's not going to work now. 1 and 4 and 2 and 2 are my factors there. And then the factors of 15 are 1 and 15. I'll have to go here now, sorry. Factors of 4 are 1 and 4 and 2 and 2. Factors of 15 are 1 and 15 and 3 and 5. Keep in mind we are trying to subtract to get 3. Seeing if my rules help me out. My middle term is odd, yes? Which means I can't use a pair of even factors. What can I get rid of? 2 and 2. Okay, so that eliminates my options just a bit. So I'm going to use the 1 and the 4. And again, I generally don't use this one in the beginning. That's not the first one I try because we very rarely use it. So I'm going to try the 3 and the 5. I'm going to place them here and see if that works. What do I get when I multiply those two? 20. And that's 3. Does that subtract to give me 3? No. All right, so I'm going to try switching those and putting the 5 here and 3 here. What does that give me? 12, and that's 5. Does that subtract to give me 3? All right, so if 5 and 3 don't work, then the only other option is to try 1 and 15. What does that give me? 60 and 1. Does that subtract to give me 3? All right. So switching them, that gives me 4 and that gives me 15. Does that subtract to give me 3? Have I tried all of my options? So what did we say yesterday if we try everything and nothing works? Prime. It cannot factor. Okay, so that will happen as well with some of these types of questions. Make sure you try every option before you put the prime. We're not going to do 10. I'm just going to do